In question 1, we will be taking a look at quicksort, which is another kind of comparison sort that relies on the idea of partitioning. We first choose a pivot item P from the input list L. Partition L into 3 unsorted lists, L1, LP, and L2, where L1 contains all items less than P, L2 contains all items greater than P, and LV contains all items equal to P. We then recurse on L1 and L2, giving S1 and S2, and concatenate S1, LV, and S2 together. So in 1.1, we are given the following unordered list, and we will perform quicksort by choosing the first element as the pivot each time. So in the first step, we choose 18 as our pivot, and in the next line, we have the left sublist containing elements less than 18, the middle one containing all elements equal to 18, and the right one containing elements greater than 18. We then recurse on the leftmost and rightmost sublists. When we recurse on the left list, we choose 7 as our pivot, and since 7 is perfectly in the middle, that side returns 4, 7, and 11. We then recurse on the right side with 22 as our pivot, and when doing so, we end up with 2 sublists, one with just 22 and another with elements that are greater than 22, which include 34 and 99. Now we recurse on the list containing 34 and 99, using 34 as a pivot, and now we have our sorted list. Next, we want to analyze the best and worst case runtimes of quicksort with Hoare partitioning on n elements. So in the best case, the pivot is always the median, which will result in a well-balanced recursion tree. Since at each recursive call, we iterate through the input list to split it into 3 sublists, we perform theta n work per level. And since we split the lists into exact halves each time, we have theta log n levels, which results in a total of theta n log n for the runtime. In the worst case, the pivot is always either the smallest or the largest item in the input list, and in these cases, our recursion tree would be very unbalanced, resulting in a height of theta n. And since we still do theta n work per level, the total runtime is theta n squared.